I spend a lot of my time standing in locations like this, at the edge of some precipitous cliff along the Causeway coast, gazing down on the crashing waves, surrounded by the cacophony of noise as the breakers rage against the cliffs in front of me, tasting the salt in the air. This is a profoundly visceral experience. This isn't just looking at a landscape. This is being right in the middle of it. The ultimate, not virtual reality, but reality experience. When you're standing on cliffs that were formed 60 million years ago, whenever the Atlantic was ripping itself apart, and volcanoes and fissures spewed out lava all across County Antrim, layer upon layer building up, forming the dark, grey, black basalt rocks that have stood the millions of years since they've been formed. And then around about 11,000 years ago, whenever the last ice age finished and the glaciers retreated and the sea levels changed, in those thousands and thousands of years since then, day after day, the sea has raged against this landscape. The never-ending battle, basalt versus ocean. And to stand in a location like this and to see the beauty in front of me, and yet to understand something of the processes that are going on and have gone on and will go on long after I've left this planet, to shape, to sculpt, to form these beautiful things that I'm standing looking at. These are moments to treasure, moments to get perspective, moments to find yourself. Oh, but listen, we have a job to do today, and that job is to explore some of the geography of these locations. So I'm going to take you on a journey, and I'm going to immerse you as best I can using Google Earth into some of these locations. And as we travel around in the journey, I'm going to open up your eyes to understand more of what is happening. So the next time that you stand in a location like this, the next time that you find your breath being taken away by the beauty in front of you, you'll be enjoying it on a whole other level again. So let's jump in and take a look at our coastal landforms. So we're going to start off with landforms that are formed mostly by the processes of erosion, and they are cliffs and wave-cut platforms. That's what we're going to start off with. So we're going to take a journey around the British Isles for a few of these things. The cliffs and wave-cut platforms. We're going to go to a place that many of you will have been, a summer day trip favourite, up to Portrush. Now over here we've got Barry's, and these are the beaches you will have played on, but we're coming over here to an area called Black Rocks to understand a little bit more of how these features are formed. So what you can see here, and it's quite handy that we've got the shadows of the sun, it shows you the height. These are the cliffs, there's the shadows of the cliffs there, and then these are the features that are the wave-cut platforms. Now you probably will have gone on to something like this at some stage. These are where you've got your little rock pools. If you've got your little fishing rod, and in you would go, your little net, and you would go fishing in those rock pools. So a wave-cut platform, that's what they are. So let me tell you what a platform is. This is a relatively flat, raised area that sits out in front of the cliffs. Let's go and have a look at a 3D view of this and understand a little bit more of how they're forming. I'm just going to swing the orientation around so the orientation is similar to the way the diagrams are here. Now, the first thing that I want to say to you is that the processes that are forming this are similar to some of the processes that we meet whenever we're looking at the formation of waterfalls. Because if you have a wee look here, we've got notch. Now, The notch is just in there at the bottom there. At the bottom of the cliff, there's the notch cut out. And it's cut out because during high tide, the water will come over the top of this Wavecut platform, all the way to the base of the cliff, and the waves will break at the base of the cliff. Let's have a look at what happens as a result of that. So the waves are breaking at the bottom of the cliff and the notch is eroded. Now this is where it's similar to waterfalls, isn't it? Because what's going to happen next? If you've got a notch, what's going to happen to this material up here? You know the answer, don't you? That material is unsupported and therefore collapses. Let's see what happens next. There you go. This is collapsed now. The former material is collapsed. The cliff has retreated. A new notch is being formed and we're beginning to get the Wavecut platform being left behind. It's raised up. And it is relatively flat, and at low tide, when the tide's down a little bit more, it's exposed. So that process just continues over time. The same kind of process that we would have met with the notch in the waterfall. The notch is cut out, the material above is unsupported and it collapses. The other thing I'd like you to note is how that makes how that makes the cliff steeper over time. Because this material is collapsing down and under the influence of gravity, so you get this really steep cliff here. So you end up with a steep cliff, the notch and the Wavecut platform exposed at high tide. Now here you can see this particular area that we've just visited at Blackrock. This is what it looks like in an Ordnance Survey map. So I want you to notice the symbols there for Wavecut platform, because if you've got to use an Ordnance Survey map to find them, that's what the Wavecut platform looks like. There's the black line that shows the cliff and the coast, and then it's those little symbols that show you the Wavecut platforms. So that's feature number 1, the cliffs and the Wavecut platforms. Erosional feature number 2, caves, arches, stacks and stumps. Now for this one, we're going to leave Northern Ireland. We're going to go on a journey here to the southern part of England, to one of the most famous locations in the British Isles for this, and it's Old Harry. Now the first thing that I need to point out to you is that this is formed at a headland. What's a headland? Right, well you can see very much here, there's the headland. It's the part of the coast that protrudes or sticks out. Headlands are often found beside a bay, and there's another headland. So you can see very much here how these headlands are protruding or sticking out, and there is the bay. Now, because the headlands are sticking out and protruding out, that means that as the waves come in, you can just about see them here, these wave crests bending around this headland. Do you see that shape? Bending around the headland, and as it bends around the headland, it concentrates the erosion here. It concentrates the erosion here. So the waves, as you can see in this, are converging from both sides, and those erosion processes are taking place on either side of the headland. Now let's see the effect that that has. We'll come down here to street view of this, and here are these headland features that we have just explored. There's the headland, so you can see the waves eroding in here, the waves eroding in here. I wonder, do you know what type of rock this is? We have rock similar to this in the north coast. It's limestone, it's chalk, it's a form of limestone. But you can see here a number of these features they're beginning to sit out. Now I'm going to take you and in your imaginations at least around to this location here, and we're going to look on sideways. So imagine that we're looking on sideways from here over to here, and this is what we see. So what we're going to do is go along these in turn, because the features that you see here almost like take you back in time. It's a journey through time to see what's going on. And it starts off because you will have places in the rock where you'll have cracks or fissures. These are things that are formed by these incredible processes that move the rocks around whenever these tectonic processes are moving or cross over the surface of the earth. And whenever the waves break either side of that, you're going to get the erosion concentrated there. These are areas of weakness that cause the erosion to be concentrated. And what then happens is that as the erosion is concentrated here, the crevices get wider and wider to form a cave. But the thing to note is, remember, this is a headland, and the waves are approaching from this side. The waves are also approaching from the other side. So it's like a cave is being dug out here, and a cave is being dug out the other side as well. And they haven't met yet, but as that cave gets bigger, as it gets wider, as the top collapses, as it gets deeper, eventually it will go all the way through. It will meet in the middle, and the top will of the cave keeps collapsing down to produce this arch, this feature where you could easily go through this arch. And as the hint shows you here, eventually that arch, because it is unsupported, will also collapse. And when it collapses, it leaves this freestanding pillar of rock called a stack. And guess what? Over time, the stack is eroded too, and it gets smaller and smaller and smaller, leaving the last feature here being a stump. So all of these features can be seen on a headland. This is the oldest one. This is going back in time, if you like, and this is the newest one forming. Eventually, given enough time, this will widen out into this, will widen out into this, the top will collapse to produce this, and eventually it will erode down to give you your stump. Here is an Ordnance Survey map, again showing you the how these features are shown. Now this is the Ordnance Survey symbol for the cliff. There's the black line showing the coast, and there this time those little inundated lines here are on the landward side of the black line. That's what shows you this is a cliff. The Wavecut platform symbols are similar, but they are on the seaward side of the solid black line. So that's how to tell the difference. The solid black line shows you the high water mark. If the symbols are to the landward side of the high water mark, that's a cliff. If they are to the seaward side of the high water mark, that's your Wavecut platform. And then we'll come down here and you can see at least the aerial view of the stacks and the stumps there. You'll not be able to see the arches, but there are arches in there. Right, those are the erosional features. Now it's time to go on to our depositional features, and the first of these is beaches. We're going to take a look at three things for the beaches. Where they form. You've already got a hint of that, haven't you, in the low energy environments. How they form. Well, that's going to bring you back to some of the processes that you'll have covered before, like, well, what moves sand along the beach? What are the processes? Do you remember? You've got longshore drift and you've got your constructive waves. And then we're going to look at some of the beach characteristics. So let's jump in, and we're going to go back to Northern Ireland for this one. We're going to go near Bushmills to a lovely little beach called Runkerry Strand. This is the Bush River that comes down here and flows in, and again you can see the beach in the bay and the headlands. So let's have a wee look at the annotation on this first of all. Just like we saw in the last location that we visited, there are a couple of headlands sticking out here, and this is your bay. Now, because this is a bay, if the headlands are high energy environments, guess what the bays are? Low energy environments. You've got it. Yeah, there's less energy. The energy is spread out here. It's concentrated here. It's concentrated, lots and lots of erosion. Spread out here. And because the energy is spread out, because there's less energy, oh, you just too tired to carry it anymore. You just want to deposit it, and you get your beach formed here in the low energy environment. So that's where they form. They form in bays, typically in low energy environments. Now, where does the sediment come from to be deposited into the beach? And there's various sources that it can come from. One of them is brought down here by the river. And in fact, many of you have been across this little bridge here. If you go across the bridge, the river is quite shallow here, but very, very often whenever you see the water flowing into the sea, it's this real peaty brown colour because of the erosion of the material and the transportation of the sediment down the river. And as it's carried down here, you can really see that lovely colour in the water. It's beautiful. And that's one of the sources of sediment that can be brought out here and then brought onto the beach. Another place where you can get the sediment is by erosion of material from the headland. As that material is eroded off, it's going to form chunks of rock, but then they're going to be broken down into smaller and smaller particles. What's the erosion process that does that? Do you remember? Rocks hitting off other rocks, becoming two things. What are the two things? Do you remember? Yeah, it's attrition, and the rocks become smaller and more rounded, and eventually they become small enough to be sand-sized particles, and they can go into the beach as well. You can also have your your constructive waves. You can see them here. This is actually a very dangerous beach to swim in. It's not somewhere where you should swim at all, because they're very strong rip currents here that can pull you out. But the constructive waves here are bringing the sediment onto the beach as well, and you can have longshore drift occurring here as well. Let's just take a quick look at the OS map symbols for these, because this will summarise for us a little bit of the different kinds of symbols. So here we have, again, remember the black line represents the high water mark. There you go. If the sand is to the seaward side, it's your beach. If the sand is to the landward side, it's the sand dunes. If it's just orange, it's sand. If it's orange with speckled dots on it, it's shingle. What's shingle? Well, those are pebbles. The pebbles in the beach. If it's orange with that blue water over the top, it's the mud. The edge of the beach represents the low water mark. And then back to the point that I just made to you about the symbol, you can see that the symbol for the flat rock, that is called the flat rock, that's your Wavecut platform, and the symbol for your cliff, they're similar. How do you tell which is which? If it's to the landward side of the black line of the high water mark, it's a cliff. If it's to the seaward side of the black line, it is your Wavecut platform. So let's move on then to take a wee look at the beach characteristics. Let's imagine that we're standing here on this beautiful beach. Oh, look at that. Oh, wouldn't it be great to be there? Now, I want you to notice something about this, because this beach is a good example. There aren't too many examples of the North Coast that are like this, but this is a good example of showing a beach that has both sand and pebbles. Shingle. You can see that. Now, notice where they are. Notice that the sand is closer to the sea and the shingles are further on up a little bit. So we come into this to take a wee look at some of the characteristics of these beaches whenever we come and explore them at coastal areas. So typically the sand will have a more gentle gradient to it, and the shingle will have a steeper gradient to it. The shingle will be at the back of the beach, and the sand, as we've seen in the photograph, will be closer to the front. Now, why is there a difference in beach gradient? Well, let me see if I can give you some clues. So this is to do with the swash, it's the water coming in when the wave breaks, and the backwash, that's the water leaving whenever it comes back down the beach again. And it's also to do with a process similar to the one that we met in rivers, whenever water enters into the soil, beginning with I. What's the name of that process? Did you say infiltration? That's exactly it. So here's a question for you. What type of beach material does the water find it easier to infiltrate in? What type of beach material? Is it sand? Or is it shingle? Which type? How do we think? Okay, let's follow through the logic then. In the sand, you have the sand particles are closer together. Because they're closer together, there's less infiltration of the swash that can occur. And so there's more backwash. Because there's more backwash, you're going to be moving material from the top of the beach down to the bottom. However, the pebbles, the shingle. The spaces between them are larger, much larger. Because they're much larger, the water is much more easily able to infiltrate down into it, and therefore there's less of a backwash, or at least the backwash kind of filters down through the rocks rather than over the top of them. And as a result of that, then the swash tends to move the pebbles up the beach, and that's why it's steeper, and that's why the shingle is found right at the top of the beach and the sand at the bottom of the beach. So that's the first thing to notice if you've got both sand and shingle. Not very many beaches in the north coast of Northern Ireland have both. Runcarry Strand is a good example of that. Right, next up, some of the features that we have on the sandy beach. You will have what are called ridges and runnels. A ridge is a slightly elevated part of the sand. A runnel is a slightly lower part of the sand. This photograph shows it here. Now, if you've ever gone walking out, not at Runcarry Strand because it's too dangerous, but if you go out somewhere like West Bay and Portrush, if you ever walked out there into the beach or into the sea, and it gets deeper and deeper and deeper, and then all of a sudden you find it getting a little bit shallower again, and then it getting deeper again. If you've ever had that experience, you're walking over ridges and runnels that are underwater. Now, when the tide goes out, you can see them exposed. You can see these ridges here, the higher bits, and the runnels here, the lower bits. So those are some of the features you'll get on the sand. In terms of the shingle, up towards the top, it is definitely steeper, which you can absolutely see here, and you tend to get these raised ridges. These ridges can really be quite steep and called berms. And these are whenever the tide just brings the rocks up a little bit further and causes them to stack up in that much steeper location and steeper position. And then right at the very top you've got your storm beach. This is formed during the biggest storms, whenever the tide and the waves combine together to throw material right up to the top of the beach, and you'll see bits of seaweed up there and driftwood and all sorts of things. That's typically away from the influence of the sea and is formed whenever you get the biggest storms, but you'll get a series of berms. Now, notice again, the sand is closer to the sea and the shingle is further on up. So a quick summary photograph here. There's the sand at the bottom of the beach, more gentle gradient, and there's the shingle at the top and the steeper gradient of that beach. And of course we need again to take a wee look at the Ordnance Survey map to see how the Ordnance Survey map shows this. And you can see again there's the black line showing you what do you remember? It's the high water mark. There is the sand to the landward side of the black line. Do you remember what that means? Yeah, it's your sand dunes. We don't need to study those for GCSE, but you'll be aware of those. Those are the dunes you've gone and played in if you've ever gone to the beach. And the yellow colour to the seaward side of the black line is your beach. There it is. There's the Bush River coming in here, feeding in the sand. There's your headland. There's your black line showing the high water mark, and these symbols here show that this is a Wavecut platform. And you can see some more headland features here. There's a cave as well in there. So there's your headland, your high energy erosional features. Here's your bay, your low energy depositional features. And let's just take one final little view of this beach before we go. If this will let me. Oh, Street View isn't taken. I didn't play ball today. Well, you'll just have to use your imagination. Beautiful beaches to go and stand on. Right, the final feature that we need to take a look at is our second of our depositional features, and this is something called a spit. So let's leave Runcarry Strand behind. And again, we're going to go all the way over here to England, to the south coast of England again, to one of the most famous spits that we see in this location. So let's come in a little bit closer and have a look. So this is our spit here. So what is a spit? It is an elongated beach. It's quite linear there, isn't it? That sits out from the rest of the coastline. You'll notice that it has some hooks or some shapes at the end here. And you will notice this is something that's very important. This forms where you get a sudden change in the direction of the coastline. And this is our spit. So, we need to go through and look at some of the characteristics of the spit, but we're going to start by taking a look at the factors that need to be in place for a spit to form. You need certain conditions or characteristics of the coastline for these spits to form. And the first one is that there has to be longshore drift happening. Now, I reckon that there is evidence here of longshore drift. Can you see it? So what we have here are these groins sticking out from the shoreline. Now these groins are meant to interrupt longshore drift. They're used in a series along a coast to try and hold on to the beach. So let's see if we can figure out and explore this carefully to see what evidence that we've got here. Now, is the longshore drift here happening from left to right or right to left? Interesting one. Now there are clues here that are going to help you. There are absolutely clues here. Remember, with a longshore drift, the waves approach at an angle, and the waves go up at an angle, back down, straight. Up at an angle, back down, straight. Up at an angle, back down, straight. Up at an angle, back down, straight, and so on. So, is there evidence here that the sand is being taken from here and trapped by the groin here? Or is it the other way around? Is there evidence that it's being taken from here and trapped by the groin here? Where is the sand moving? From here to here? From here to here? From here to here? Or the other way? Left to right? Or right to left? Vote now. Let's see if you're right. If you said from left to right, you are correct. And if you look carefully, you can see the evidence from that. The longshore drift is coming up at an angle, back down straight, up at an angle, back down straight, up at an angle, and then it hits the groin and it has to stop. So you can see here you've got a build up of the sand here because the groin is trapping it, and you've got less sand here, and the sand is moving all the way here, and it's building up here because the groin is trapping it. So there's more sand here than there is here, moving. You've got this movement from left to right. The longshore drift is moving along the coast, and those groins are trying to trap it. So that's the first of the conditions that we need. We need longshore drift to occur. The second of the conditions that we need is a sudden change in the direction. Now, if you look at the yellow line here showing the coast, comes along here, and then there's this sudden change in direction, here to here. Let's go in closer and have a little bit more of a look. You can very much see this sudden change in the direction if we have a look at the road. It's coming along here and then down there. That's a 90-degree bend in the road. Now, this is street view, it's meant to be allowing me to move around, but clearly we're having a few bandwidth issues here. But you can absolutely see that 90-degree bend in the road. Right here, turn left. Come along here, turn right. You have got the very sudden change in direction and orientation of the coastline. And whenever you put those two together, those are the conditions you need for the formation of spit. So let's take a look at our annotated images for it. So we've already discovered we've got the longshore drift up at an angle, back down, straight, up at an angle, back down, straight, up at an angle, back down, straight. Yeah, you've got it, haven't you? And then there's this sudden change in the orientation of the coastline. So how does that form the spit? Well, here's my question for you. Whenever you get the longshore drift coming out here to the sudden change in the orientation of the coastline, does longshore drift carry the sand around that change in orientation, or does it carry it out in the original direction? And that's what starts to build the spit sitting out from the coast. The longshore drift carries this in the same direction as before. The coast changes direction. The transportation of the sand and shingle and longshore drift does not. And that's what then forms this linear deposition, this linear pattern out into the sea. That is your spit. There's a couple of other things though that we need to notice here. So these features at the end, let's have a look at those. Sometimes you can have a change in wind direction. It'll come mostly, our winds mostly come from the west, our waves therefore mostly come from the west in the UK. But sometimes you can get, remember the beast from the east? You'll hear about that from time to time. The winds will approach from a different direction, and when they do, they cause the end of the spit to hook around. Now you can see it's carried around like that by those waves. And in fact, you can see the ends of former hooks further back here as well, evidence that this has grown out and out and out over time. This used to be the end, there was the hook. Then it moved further, this used to be the end, there was the hook. Then it moved further, this was now the end, and there's the hook. So you've got your spit forming out, this linear pattern of deposition. You've got your hook at the end formed by your second dominant waves. Well, what's this feature in behind? Let's have a look at it. What this creates is a low energy environment, because you've got the spit protecting the area in behind from the waves. And when you've got a low energy environment, when you've just run out of energy, what's the process that happens? I'm so tired. Oh, deposition. Deposition. That's what happens. So you get the deposition in behind there. But in this case, it forms what's called a salt marsh. And here it is, lo and behold, in our Ordnance Survey map. Okay, let's have a look. Here were the grounds that we started off with, so that was our evidence that longshore drift is happening. Question for you, is that a sandy beach or a shingle beach? Sand or shingle? Sand or shingle? Yeah. So the shingle on that beach as well, that's what those dots are. Okay, and there's our 90-degree bend in the road, remember that? Turn left as you go around there. And then here comes the beach. Sand and shingle here as well. And then behind, now remember in the symbol I showed you whenever the sandy colour was covered with the blue, do you remember what it was a symbol for? It was mud, and then those little blue things on there are showing that's your salt marsh. So that's your symbol for your salt marsh. These are very often places of important ecological areas that are good places for habitat diversity. You'll find a range of plants and animals adapted for that particular location. Fingers crossed its Street View is going to work for us a little bit better this time. Or is it letting me move around? It's not. That's a shame. Anyway, you can very much see the shingle here, can't you? There is the seaward side of it, there's the shingle ridge, and right out at the end there's the hook, and in behind is your salt marsh. The muddy areas that have some of those river tributaries flowing through it, but those muddy areas, and that is your salt marsh in behind. So those are our features. We've got our cliffs and our Wavecut platforms. We have got our headland features, caves, arches, stacks, stumps. We've got our beaches, and we have got our spits. So the last thing we're going to do is just visit another couple of locations around the British Isles and tell me what coastal features you think are visible here. What are we looking at here? Can you spot it? This is, well, it's certainly a beach. You can absolutely see at the end, though, some evidence here of little hooks and so forth. So this is just kind of the beginnings here of a little bit of a spit. And you can see very much the direction of longshore drift, can't you? You see the patterns in the waves here carrying this material out. So you've got beaches there and a wee bit of a spit forming as well. And finally, we're going to leave North Norfolk and go to Donegal. beautiful county of Donegal. And we have here Tranarossan Bay. So the beach has formed in here. Why? Why? What is it about this location in Tranarossan Bay that makes it a suitable location for the beach? Now have we look, see what clues you can see here about the energy. Look at those breaking waves around the headland, right? Think of all the energy there. There's your Wavecut platform, can you see it? And your cliff, your flat land in front of the cliff. A raised platform. So this is your headland, and you come in here, you go from all these breaking waves to this low energy environment in the bay. Can you see the waves there spreading out as it comes into the bay? So where the waves are concentrated at the headland, they're spread out here. And because they're spread out, this is a lower energy environment. And because it's lower energy environment, what process are you going to get? Yeah, it's deposition. And you're getting the constructive waves that are bringing the sand into the beach. Donegal is a fabulous place for a lot of these kind of hidden beaches. This beach here is a brilliant one. It's called the Murder Hole. If you ever got a chance to go and visit it, it's absolutely beautiful. The sand here is so golden. The sea colour is that beautiful aqua colour. But anywhere where you've got those little bays, you're getting these beautiful little beaches here. If you've got a caravan in this location and that's where you're right beside, what a wonderful location you are. There's another little bay, low energy environment, another beach in it, another little bay, another low energy environment, another beach in it. And there's your headland features. Look, everywhere where there's bays, there are beaches being formed here. There's the sand dunes in behind them, and you just see this. It's a great thing to do, actually, just to go around Google Earth, and Donegal's a fabulous place for it, because look at all those beautiful features that you've got there. Okay, now that's our tour around the features. So we've had our erosional features of our cliffs and the Wavecut platforms, our headland features also formed by erosion, which are your caves, arches, stacks and stumps, your depositional features, which are your beaches and your spits. And hopefully that tour around the British Isles has given you a little bit more of a sense of what these features are like. And the next time you're standing on the cliffs looking at them, being inspired by the scene in front of you, I hope you remember some of these exciting processes that are going on. I hope you remember just a little bit of your geography. It's okay to be a geek. It's okay to love geography. It's pretty cool.